Hey YouTube, it's JP Dillon. Welcome to part 4 of the Toshiba C321 repair and restoration. Today we're going to finally pull this sucker out of the cabinet, and we're going to go over the power supply, change the power supply caps. I don't know if it'll make it to this episode, but we'll definitely try yanking the IF board and the video output board and checking all the components on those. Very likely recapping both, just because they sit in an inaccessible location and I really don't want to have to yank them and deal with them again. So we'll be thoroughly testing components on those, but that might be part 5. So anyway, let's get the set apart and let's see if we can get the chassis yanked out. Alright, so at first glance, this thing looks pretty intimidating. But thankfully, I do have the service literature. And if we look at the service literature, it's pretty straightforward. You can see that the entire subchassis just comes out. Obviously, we're going to ignore the picture tube. That's going to stay in there. But the entire chassis should come out as a whole. Excuse me. And what that more or less entails is disconnecting all of the paraphernalia from the picture tube. So the CRT board goes, the convergence unplugs. You've got the convergence board here and the magnets, and then you've also got the yoke here which disconnects, and then finally the high voltage connection back here that needs to be discharged, and then we can focus on taking the chassis out. Now this isn't so difficult if we look at it. I mean, basically you have screws along the top here that hold the chassis in, and then along the bottom, not sure if you can see, but you have screw here holding the chassis in. There's no more than that. And then we have to take off all the knobs. And then also on the side panel here, I don't know if you can see that, there's a screw here and a screw here holding this sub chassis in. So those have to be removed. And then of course the tuner and front knobs need to be removed. And in theory, this whole thing should come apart with ease. Well, yeah, that's the theory. So the first thing I'm going to do, just for the sake of safety, is discharge the CRT. Now, there's a number of methods you can do this. You can do it with a high voltage probe if you want to wait. You can do it with your own contraption of alligator clips to the chassis. However, what I'm going to do is pretty plain and simple. I'll show you here in a second. And what I'm going to do is I just have a small, slender, flat blade screwdriver like this and an alligator clip. The alligator clip gets clipped to the screwdriver. The other end of the alligator clip gets clipped to the chassis. And there are usually instructions to discharge. And they have it listed here, to measure or discharge high voltage, negative to chassis, to measure high voltage probe to second anode, which is this cover, blah, blah, blah. So basically we're just jumping this to ground. I'm going to connect this to the chassis here, and then we're going to slip this under the ultra connection, and you can probably hear a little snap from the high voltage. I don't know if you guys heard that little tick. And I'm just going to hold it there for a good 30 seconds. Okay, that's pretty secure underneath there, so I'll just actually leave that there to let it finish discharging. And then we'll unplug the yoke right here. Then we'll unplug the convergence board and the convergence assembly here. I'll go ahead and start pulling knobs off of this thing. Some of these are kind of stubborn. I don't want to break them. Alright. We'll go ahead and pull the knobs off the front. Okay, so the knobs are off there. Let's go ahead and remove these side panel screws here. This one was loose. Well, that means that someone was in here before. This also was loose. Screw comes out. And the screw comes out. Let's go ahead and do the bottom ones here. It's nice not seeing a bunch of rust and stuff on this. Yank those two screws there. And just as a check, that does give us our mobility. So let's unplug the CRT board. This should be discharged by now. And let's disconnect the altered connection. I'm just going to give it a pinch here, push it to one side to unhook it from the CRT, hopefully. These aren't as cooperative as they should be sometimes. Alright, and then let's do the top screws here. Looks like we have a 1/4 inch hex nut there too, definitely suggesting someone serviced this before. And given the fact that the plastic's crumbling there, I'm guessing they used a thicker gauge screw because the plastic is old and tired. Come on out. Okay, let's switch to a 1/4 inch. And take that out. Definitely different gauge screw. I'm going to make a little dot there so that I remember to put that 1/4 inch nut back in there. Now here comes the fun part. It's taking this out, and we're going to hopefully have enough slack in there. Let's see here. It looks as though the tuner wants to stay. The tuner's bolted into the cabinet separate from that. Let's see what's required to get this apart further. Can disconnect that ground. Let's release the antenna block here, since that's still connected to the tuner. Give us a little more slack. Let's disconnect the front panel here. And how much more movement do we get from that? Nope, there's still another set here. This looks like a ground strap to the tuner. These things aren't depicted in the service manual. Just gives you the illusion that it comes out really easy. A little more freedom. Alright, what else? Gotta be more here. Or let's see. That's not really accessible. I was going to say pull the tuner out, but that's not really that accessible. Let me just get in your way here for a second. There we go. Something just came loose. So it looks like, given the amount of cabling that I have attached to this chassis, we're going to have to swing this out. Let's make sure all of this stuff is very much out of the way. Appears as though I'm going to have to release the convergence board fully, which is okay. Try not to let it dangle by its wires too much. And this should allow us to swing this out. That's going to want to fall. This is more or less testing the tensile strength of everything on the set. There's the degaussing coil. Let's unplug that. We're getting closer. Alright. Yeah, the rest of that does not unplug. But we do have access to the tuner screws now, which is helpful. I want to make sure that this doesn't fall back and neck itself. That would be embarrassing. And probably a near impossible CRT to find. So I'm going to come down here and see what screws are required to get this out. Because I can't see much of anything inside of there. So at the very least, I am going to release the tuner. Let's see, can I lift up on that? Not quite yet. They certainly make this not easy. It looks easy, but it ain't. Let's pull this board loose here. Okay, that at least seems loose. And then let's see if there's another screw down here holding this in. Yes, there is. Between the volume control and the contrast control. Must be another one I'm not seeing. Isn't this fun? See, these are all the things that the service manual doesn't tell you. Let's look for the hidden screw, hidden screw, hidden screw. I got the two up top there loose. I don't think there's anything additional that I can see. Although it could be that this side panel board is preventing me from getting it out completely here. See if getting that loose helps me at all. It just feels like there's another impediment. I just can't see it. Alright, so let's remove this bottom screw completely. Yay for magnetic screwdrivers. That gives us the freedom we need. Alright. It's the little things. Out comes the tuner. This is a very fun juggling process, isn't it? I'm trying not to let the chassis fall off the bench, nor let the CRT fall down on itself. Alright, I don't have to deal with that. Okay. So what I'm going to do, my phone is actually propping this thing up by the yoke, by the way. I think that's the only reason why it's not falling over at this moment. So now what I'm going to do is move the chassis temporarily, very carefully here. And then we're going to get the CRT out of the way for sure. See, without the phone there, it would just fall right over. Okay. They do have some uses. So let me get this out of the way, rest it on its face, and then stick the convergence board over there so it's better supported. Oh look, a tag. Some sort of tag here. Chassis connected to one side of the line, picture tube dangerous to handle, discharging to main chassis only. Yeah, we did that already. Alright, let's get this out of here. And let's get the chassis back up on the bench. And see what we couldn't see before. That's assuming that I can get it back up on the bench without destroying things. So this is the front of the chassis. This is what you don't see when it's in the cabinet. Let's zoom in on that just a pinch there. So you've got these big filters here, this here, these smaller ones here. Damper tube, horizontal output tube. This is the IF chassis, which we'll be looking at for sure. And this is that video output board, which although I thought it looks like it swung out, it still doesn't look like it swings out. Even if you take this loose, this board comes down, but that still doesn't change the orientation of that. It just looks like one of those things. Oh, this is the power supply board, never mind. This is the power supply board here. Behind it, yeah, power supply board behind it, and then this, I guess that is your video out, because it does have all the transistors mounted here. Well, anyway, we have service literature that will tell us what it is. So let's first start by checking the power supply components and see how bad any of them are. I'm going to replace them all just for reliability's sake, but out of curiosity, let's check them. You may remember this set operated, it just operated poorly. And we did see some hum and ripple in the picture, so we're going to check and see how bad these things are. That's okay. That's okay. That tests really good. Let's look at this doubler here. Good ESR there. And the other half of the doubler, also good. So why were we getting this scary ripple in the picture? Well, let's check these other caps here. That checks alright. That checks alright. That checks alright. Interesting. Why do these all measure like better than perfect? That seems strange. I find it hard to believe that a set of 50 plus years old, well actually it's not quite 50, is it? No, it's getting there. 47. 47 years is perfect, especially since we saw hum and such in the picture. Little safety cap there. Interesting. I wonder what the meter says. Make sure we don't have any strange resistances to ground, because those caps test awfully good. That charges up. That is charged. And let's look here. Find it really hard to believe that all of these are like perfect. Especially considering we saw hum in the picture. Maybe there's a regulator problem. These are obviously your low voltage caps. These don't charge up very much. 500 ohms off ground. And the other terminal back here probably is ground. Yeah, that's what that is. It's only 300 ohms off ground. So this is very likely all our low voltage stuff. This is probably ground, yep. Okay. Now they certainly don't make that low voltage board easy to access, but I would be curious about that. Here's some more voltage divider resistors here. 3.4, probably a 3.5K. That one charges and discharges, so there's a capacitor shunting that. 18K it's settling on, looks like. Here's some of these Japanese oil-filled jobbers. I don't trust them. There's an old electrolytic back here. So far, these all test pretty much perfect, but I question that because we saw some hum in the picture, and obviously our IF strip isn't doing very well. So I wonder about that. Also, what's true, somebody's been inside of this IF can before, because look, all the screws are missing. Isn't that something? I wonder how we can get up in here easily. Maybe the service literature will tell us. Oh, more spam. Get about 48 billion spam calls a day. So the service literature doesn't really tell you how to get it out, it just tells you what's inside. That's your IF board right there. Then we've got our power transformer, choke, vertical output transformer, so yeah. Anyways, and then our other boards, chroma 1 and 2, sound, video, vertical, horizontal. And then the drive board, which is on the CRT. And one thing it doesn't really explain very well is what these two boards are back here. At least I don't see them listed. I'm guessing that's a regulator board of some kind. We just kind of look through the schematics here. We've got our tuner, AFT, UHF. There's the insert there. Chroma 1, Chroma 2 video, IF, horizontal, sound, and there's an AGC board. Interesting, this AGC board up here. Maybe that's what I'm looking at in the back? That doesn't make sense. They don't list that as an option here on the circuit boards. Yeah, I don't see that AGC board there. Not listed on the top and rear views, top or bottom. Do you see it? Because I don't. So maybe that was one of those things that they advertised, hey, don't mess with this. And there's a number 2 on this board over here, but I don't see that reference to anything either. So I think some exploratory measure is in order. Unless there's a missing page, I don't think there is. Let's just pop this out of here and see what this is. This could be the quote-unquote AGC board. This comes out really easy. But I would figure that there would be more to it than that. This board interfaces with the IF board. It also interfaces with the CRT board. Oops. There I go whacking stuff again. Let's see if I can undo this twist tie and get a better grip on this. Let's release this too. This is kind of getting in my way. Alright. PW723. That's probably our AGC board. Unless my memory sucks and I can't remember it. 732, am I dyslexic? Yep, 732A. That's the AGC board there that we can't get access to from the behind. That could have something to do with our crummy video response too, so I really need to go over that. And then trying to run that silly thing with this board up and out, that's going to be tricky. Let's get some dust off of here. There's only two little capacitors there, which they do mark from the back side. There's no slack on this thing to get around it. Let's just very briefly check the two capacitors on this board. I'm probably going to replace them anyways just because of their location. That's okay. Like I said, still probably going to change it out. That's very dead. Alright, so those two caps for sure. That will go on the list of things as part of a recap. And that back there is most certainly your power board. Let's just pop the camera out so you guys can see it instead of just me pointing at things. Let's get this up in here. Yeah, that's your power board. So let's find that on a schematic and see what they use for a 24 volt regulator, because that more or less controls all of the solid state. And I'm worried that there's a regulation problem, because there often is on these hybrids. So let's grab our schematic again and take a look at the power. Here we go. Here's our power drive board. Let's see what they do for a regulator. Might as well just pop this out again. So this is a very interesting creature because it's one side of the chassis is connected to the AC line. So you've got your series string heater and your direct line connection for your power. But the 24 volt system is derived off a transformer. Let's kind of zoom in here. See what they use for regulation. It's pretty unregulated, really. You've got basically just a bunch of smoothing capacitors and dropping resistors to help regulate current, but there's not a whole lot. See, we've got 12 volts going to the tuner and IF-AGC board. Not much else though. This is like really primitive. Really primitive. So I can't. It's hard to believe that there's no 24 volt supply here. That's weird. And you can see all the heaters in the series string that are open. Chroma 1, Chroma 2, sound, AGC, there's your IF. I hope none of those IF transformers are open. That's not going to be fun if that's the case. And then we could, 1N60 detectors, yay. Those are probably lossy or open. 1N60s are getting pretty clunky at this age. Okay, to a C383, to a C382, Toshiba C382, early primitive NPN transistors. So I guess the next thing to do is to see if we can get the IF board out, because that's really what I want to look at next. So looking at this, it looks as though it does come up and off. At least that's the theory. The question is, can we get to it that easy? I'm going to bet the answer to that is probably no. Someone's been at this before. Oh, they left one screw in. One screw in the side here, probably to maintain the ground connection. Let's see if that gains us more access. Something holding it back here. Can't really see squat. Got to take loose this clamp so it's out of the way so I can twist and manipulate it if need be. Yeah, this thing does not want to let loose. Feels like there's something holding this in. And then there's, looks like a clip back here. Yep. And I just clip back into place. Nice. Oh boy. This is proving to be a very difficult set to disassemble. There we go. That's what I want. And the rest of this does come up. So I'm going to mark these two connections here that attach to the board. And we're going to say ground and signal. Because I know me, and I will mess that up. And then we have to pull this out. All direct coupled stuff. And I am very likely going to check these transistors for leakage and things while I got this apart. So let's squeezy beezy. More stiff plastic retainers. And of course the other one's underneath the shield, which is very inaccessible. Can't make it easy. Alright. Let's take the IF board out. If it'll come out. Woo. All right. So these are our IF transistors. Here, here, and here. That's probably your IF AGC adjustment right there. But again, don't go tweaking until you know. This thing only runs on 12 volts, really? I find that hard to believe. But whatever. 22 microfarad at 16. Probably in the AGC loop. Or it could be a power supply buffer depending on where this comes in. Because this is at ground and this is a pin coming off of that's pin 3 and goes right to the positive, so I'm guessing that's a buffer for the power supply. You can always look and double check that. And then you've got C130 up here. It'll focus. Come on, focus. There we go. C130 cap up there. Alright. So let's just check the two electric licks briefly. It could be that they were the ones that were causing the hum in the picture. Let's zoom in on that so we get a little bit more work area here to check this over. I have no doubt in my mind that there's going to be some issues with this board based on our experience with it thus far. Come on, clean connection. That check's not dead. Not to say that it's okay. That check's okay. Looking for obvious signs of resistor death, which I don't see any. Using a lot of precision 5% resistors here. So let's do a basic junction test on these IF transistors, because it almost acts like it's got very little video or IF response. It could be those 1 in 60 detector diodes are bad. That would not surprise me at all at this point. So we'll do a basic junction test here. No shorts there. Just give you a better eye as to what I'm doing here. So base emitter junction on the second one's good. Base collector junction's good. Collector emitter junction, that's about what I'd expect. And there's this other one tucked up in here. Might be accessible better from the underside. Someone soldered on that transistor before. So far it's about the same as the others. So I'm thinking that's probably not it. And there's no easy way to discover this without troubleshooting it in circuit, which is going to be tricky. If it weren't for the fact that it was a line operated set, I'd just say screw this mess and I would just pipe in a video signal, direct composite and audio and video signal right into the set, because I'm really just going to be using it for plugging in DVD players and stuff like that. And I'm going to guess that the remaining stuff I need to get to is probably under this shield. I don't think there were any pictures of board diagrams in here. Let me just double check real quick. I don't think there was. Basically, you're buying this for the schematic diagram and the alignment instructions, and that's about it. In fact, I don't even think there are alignment instructions on this side of it. I think there is a supplemental book that I did not get for it, for the alignment. This is basically just a parts diagram and schematic. But according to the schematic diagram, you've got your 1 in 60 sound detector and 1 in 60 picture detector, which is probably inside this can. They label it as inside this can, so that's going to be fun. D101 it says. And basically, without having this thing on and running, taking these voltage measurements here is going to be really tricky. And if it gets to the point where I'm going to have to heavily troubleshoot this IF section while the thing's just kind of in pieces laid out on the bench. That's not really practical, and I may just find a better way to isolate an AV input for it, because it's not that special enough to me that the tuner has to work. And I think I would get a much better picture just going straight into the first video amp. Just saying. So that's a possibility. More ramblings. And the only way to really figure this out is to take this apart and figure out if that diode's bad. I mean, I could cut the foil traces on the bottom of the board and install it there as well, because it looks like it's just going from the output of the third IF to the input of the picture detector transformer, and then you've got a sound trap, and then that goes to the first video amp here. And it's interesting that this is direct couple. You've got the output of the picture detector here. Oh no, you've got this little 80 picofarad thing, and then that goes to the first video amp. Interesting. Well, anyways, let's go over the power supply board a little bit more and see what really needs to be done there. This is a point of questionability, because there's no board diagram, but I can follow where the this is how it's mounted on the set. I can follow where this ends up at, but that's a point of interest. And I do have one N60s, but yeah, like I said, if I have to get down to it, I'll just inject signal directly into the video and sound, because it's just not worth my efforts to heavily troubleshoot that IF section based on where it is in the set and where I would have to have the set operate. I really need to stop rambling. But this is all stuff that goes through my head when I'm troubleshooting these things. Let's see here. You always got to be in preparation to take care of anything weird. And then, what is this? We never did figure out what this board is. This could be our PW572 that's all back up in there. Let's see what PW572 is. .572. Don't see it on here yet. Filter board 745. Video board 638. I'm going to guess it's part of the sound. Did I say that was 572? Just looking here. .638, 745, 732, 731, 640. Yeah, I don't see a 572. Oh, there it is. That's your AFT with a TA7050 for a op amp chip type thing. So I didn't see any problems with AFT. So, and this is a direct coupled circuit. There are no electrolytic capacitors inside. So we're going to leave that one be. You've got this electrolytic capacitor here. It may be that I need to remove this in order to get to said electrolytic capacitor there. That's just a buffer cap for something else. Okay. All sorts of fun stuff. Alright, so let's do some reconnaissance and figure out what capacitor values I'm going to need and how I am going to mount them. Because typically I will use terminal strips in this application. There's not a lot of room in this set. So all these ones here, we have to take a look at where they are and what their values are and how we're going to mount them. Obviously the new cans are much smaller. And these just hold in here with these clamps. So let's take a look at this guy. It's obviously part of your doubler there, 250 at 350, 20 at 350, 20 at 350. And they're labeled. So I'm going to write on here. In fact, I can write on the chassis. Where did that brush go? So this can's been pinched pretty bad too. It may still work as far as ESR, but leakage we don't really know, and we don't have the ability to take its temperature while the set's running. Not in any practical sense. So one's going to be 250 at 350, and 2 and 3 are going to be 20s at 350. Now probably the way that I'll deal with that, since the ground is at the chassis, is probably just mount a terminal strip like right here, maybe a little bit further forward like so, and then hang the caps off the front, maintaining as much of the original clearances as possible. That should get those up in there well enough. So that's thing number one. Let's check this other guy here. This is a single value can. Of course that has to fly away from me. You're a 220 at 200. So that's probably the other half of our doubler. Interesting how it's coming loose from its sheath there. 220 at 200. And we got to pay attention to where those leads go. I'm just going to mark this as the negative here. Now let's take this guy out. And see what you are. And you are a 220 at 350. Okay. Ooh, that's part of that. Okay. So, first thing we have to do, let's go get our values of caps. And for the 220 at 350s and the 220 at 300 or 200, I do have these. They are smaller than their original counterparts, and I may have other brackets that I can put in place of this or modify these brackets to work. So that's at least some step in the right direction. And let's see, that's a 250 at 350. 220, I don't think I have a, pretty sure I don't. I could do a 220 and a 100 in parallel and make that work, but I don't have a 250. I also don't have a 330 at 350, so that isn't going to work either. Anyway, just pondering here. And then the rest of this stuff, this is all low voltage stuff back here. I can just mount subsequent terminal strips and mount stuff back here. Let's just see what these are really quick, just to give me an idea as to what I'm up against. And I know this is all incredibly boring, but this is really the way that you deal with this. Oh, and you know, this just happens to be the size just about of this. I could probably clamp and tie this together to hold it to the chassis on the front here. We'll see. These are just thoughts. And let's see what this guy is here. 700 microfarad times 3. I'll probably just use 1,000. And they've got two sections tied together. So like a 2200 and 1,000. And then you've got this bleeder resistor to ground here. So let's write that down on the chassis, because I'm sure I'll forget. So 700 times 3, 18 working volts. And then let's take a look at this one back here. These caps are all still alive, but why not change them since you're back here? And that's a 500 times 2 at 18 working volts. Okay. So these will be really easy to change, because all I have to do is put a couple of terminal strips up. Like this that can be a 470. Let's get some 470s. Alright, so for the two 500s here, I can get this to cooperate. We'll see. Probably not. It doesn't look like it wants to cooperate. Woo! Let me put this down here so you guys can better see what I'm doing. What I am going to attempt to do, we're just going to make up this dual 500 right now, and I just get a little tiny terminal strip with two 470s at 35. I don't have 25 volt. 16 volt would be too small. But I'm just going to solder these up, and then I'll show you. Let's do a little clippy trimmy. Since they use the chassis as the negative, that makes it really easy for mounting these things. But let's just clip all this off. And so there it is. I've got my little bitty dual 470 at 35 that I'll just mount to the chassis where the old one was, and then wire it up. So it's stuff like that that's pretty easy. With the dually 700, they're tying two sections together, so they get a 1400 on one section and 1000 on the other. And again, it's low voltage stuff, so it'll probably be the same type of thing where I just tie two of them together, and we have those two things taken care of. And then it's just a matter of finding appropriate values for this, and then making these two things work. But yeah, so far that's kind of where we're at. Let me just make up the other one real quick here, the 2200 and the 1000, and see how that looks. Alright, so based on the size of these, I can't really use the tiny terminal strip like I did with the 470s. I'll have to use one of these, but I've got tons of them, so we're just going to wire it up here. And again, since they're using chassis ground as real ground, it makes it kind of easy. So I'm just going to put this up here, put this one over here since it is a common ground. Put these two together, fold over the terminals to kind of lock them in place, and then we'll solder them up. And a little bit of slack that I've given myself, if I have clearance issues, I can always bend these back just a little bit. let's do our ground. Okay, so that's all in there and happy. And we'll just trim our leads a little bit. And that gives us our two capacitors we need to replace this guy back here. This one's going to be kind of tricky because I know the size of that capacitor is going to be fairly significant. I could probably do another 220 at 350 and then do a like a 47 or a 33 at 350 just in parallel with it, just to make sure that that's all correct. I don't think I have enough room to go huge, so we'll set those aside. It's going to be tricky getting the big guys along with the little guys up in here, but I'll need to devise something to make all this work happy. And I think that's going to be for the next video. We've got what we need to do right now, but I'm running out of time on the camera, so we'll save this for the next part, and we'll figure out ways to mount these guys up with the new values, and then work on replacing the caps on this board, and then check over that power supply board back there and see if we can't replace that electrolytic back there that's a little tired looking. Didn't even test it. I'm just going to assume that because it's in a tight spot with no ventilation, it's baked. That's probably going to be the case. So that's all for part 4 for now. Stay tuned to part 5, and we'll see if we can get the power supply all assembled in here to the point where it's usable.